audio here? Yes. So almost forgot the microphone since there was a power outage on Wednesday when I was gone and all my things stopped working. IoT for the win. Anyways, I'm back and I'm living. Are we early? No, we are not. Actually, it's 8 o'clock already. Everything is now. Yeah. Hello Dutch. Hello Avra. Hello Fu. Hello Jumbo, Johnny, and always FF Rohan. Okay. I'm streaming on. Yay, Sonic. Was just waiting for you. So I feel like I didn't get any sleep last week. I was on the boat. Let me show you a picture. Maybe there is a picture of me on a boat. Or I will show you a picture of the boat that I was on last week. Everything went alright. No major damages have happened. Wait, where's... sound is low? What? Wait, shotgun. It's minus 20. Is it low? Oh wait. I can increase the volume a little bit. No, that's hot. Wait, no. Here is minus 15, minus 20. I don't know. This will be alright. Better? Alright. So this is the boat when I left it in Greifswald. So we actually made it to Greifswald from Berlin. You can check. Of course, there was like nice pictures. Do you want to see the Baltic Sea? Baltic Sea was too cold. Wait, where is the Baltic Sea? Where is the Baltic Sea? Yeah, here. Oh,
Genau, das ist diese Komödie, weißt du? Ja.
This is where I returned from the water. There were jellyfish as well, as always. Oh, by the way, let me show that. I got the life vest. Hey TMK. I had like the inflatable life vest, and the first thing that happened when I went on board, I released the hook, the string on accident, and it inflated, and it's it's done. So that was that. Maybe this was. It is like shaped like a hook, and thank you for the for the donation. And I just picked something up and stood up, and then the string pulled and it inflated. It was embarrassing. It was in the port of Stettin. Oh yeah, here is a pic. Here a short video how we are going. This was the strongest wind and stuff we had. Where is it? Oh yeah, here. That was the day. It was quite rainy, and we were maxing out the speed of the boat. The boat isn't very fast. You can see different boats, and it was like the weather was shitty. Oh, he sails around him by himself, and I was helping him. So he's no, the Viking ship was. We met on our on the river to Stettin. We met Polish guys who were having a Viking ship, and the guy which was what is this here? This guy looked like Ragnar Lothbrok. Yeah, look at him. He was Ragnar Lothbrok. So that was my last week, and now I'm just sleepy all time because I didn't get a lot of sleep. Yeah, you, Johnny. Probably not you personally. And me certainly not as well, but excavator fund. Let's give it 6k. That's 150 by, yeah. Foo, another 150. Thank you very much. So I wasn't slacking off this weekend. I returned on Friday at noon roundabout, so it was only 4 days, and I wasn't slacking. Look at this. PCBs are arrived, and I assembled it. Nuloli. Hi. Infinite Coda, hello. Did I miss any greetings? The Shipu, aloha as well. So, if it will focus. Kaspar, hello. Yeah, so USB microcontroller. Either optional dual 8-bit DAC or one 16-bit DAC. Op amps here for ADCs and to, yeah, it's Eisler. Here is some power, and here are voltage dividers for the buttons, and here's perf board with 16 GPIOs and voltage and ground. And on the back side I have bitluni's microset. I don't know, I could call it a lot Alenis microset. There is, I think I missed like 2 holes in the cassette drawing here, and it's like this machine readable font from the 60s or 70s, I don't know. Yeah, thank you. The first I had like to tinker around. You see here there is some gunk because I had to replace stuff like tune the DACs and also the ADCs, especially to basically optimize the range of the ADC, center the incoming audio, and optimize that so I won't be losing a much of resolution. And the DAC is also quite nice. It is quite linear, and I used 1K and 2K resistors in the DAC, so if we pull current like no, the DAC doesn't remove the DC offset removal. There is a cap on the recorder, but here we get AC in, because I pick up before on the old version I picked up the audio from the speaker, which was already DC for whatever reason. Maybe it was just inverted or whatnot, I don't know. And now I'm picking up at the volume control, and there I got the AC signal, which is quite clean. It doesn't vary with the knob. It does like the incoming signal. So we get a clean signal, and then I just pull it up slightly with a 30 kilo ohms resistor, and then amplify it, I think by 2 or something, or by 3 with the op amp, and then it's going into the ADC. So we are using only one ADC here. We could also bypass the op amp directly if we want to. There is always the option. If you look at the back side here, there is maybe, yeah, you can see the labels. Okay, yeah, you can see it. So the outer holes, the upper one is after the op amp, and the lower one is directly before the op amp, or other way around. And same with the DAC. We could attach we can basically pick up from the DAC directly, but it doesn't have a lot of power because it's 1K and 2K. And using 1K and 2K also has fewer errors, because using like 150 and 300 ohms, the MCU drops in voltage if you pull it down very much. Like when you're at yeah, there are certain values that pull a lot of current to ground and the DAC. Hello, Dusty. And yeah, there's with 1K and 2K, it's better. Now we get a straight line there. We're not jagged like the last one. I played around with stuff. Is it connected? No. Can I watch it? I think it's not connected. Okay, connected. Oh, it's open elsewhere. I have a second window. Need to find a second window with the... oh yeah, there it is. Here's the one that I wanted to use. Here we go. Oh yeah, you can already see. Maybe if I do... Oh, you can scroll. Here is the start of the packet. It's clipped a little bit up here, but I don't think that matters a lot. Let me rewind. And then let's play. Yeah, that's only 800. Oh, you see sometimes the flat line passing by. Yeah, that's an encoded packet. We can also, by the way, since I don't have like an indicator of the state of the recorder, I can check, like when I press that, then the voltage drops on the ADC here. So I could use that to see, okay, the recorder is ready. Now I would need, oh yeah, I cleaned up the code because we had a lot of stuff going on here. Oh, let me make that. Can't push it here. Okay, let's move it there. I cleaned up stuff. let me check something, because we should do the following. Oh yeah, we should count up like to 16, and let's do that. And the encoding, I think I moved everything to individual files, and the encoding now didn't change much. I give you a recap, but I have to change a thing here. So this needs to be divided by 2. I need to check that, but because this is like the decoding part, but encoding, this is our what I decided this to be the sync byte. We start with 1100 and then 1010. So 11 gives us like the lower frequency 2 waves, then we get the faster frequency. So this way, if we would sync with each individual bit, that improves like until this bit, and then when we get a match for this whole byte, then we start reading in. I implemented everything, like, but I think I need to divide this, because yeah, let's take a look. I do 32 samples per wave, but 0 has double the wavelength, double the frequency. So we have only 16 samples per wave on the higher node. And what I am doing right now is I have a buffer where I maintain, it's like a circular buffer, and I maintain like the history of 32 times 8, because 8 bits. Shouldn't do it, but we can change this and just. I'm not sure yet if we should only decode 1 bit at a time, but this would help us. If we have the performance, I would like to decode byte at a time and also synchronize the whole byte. So I fill it with silence. Oh, wait a second. We need to shift this already. Okay, so this will be 0. Already a mistake here. Because we are decoding a byte. Okay, let me check that. Why buffer? Oh, wait a second. Yeah, that's all right. So this is basically reading until our data buffer is full. And we are just waiting for the next sample. So I just calculated the ticks per sample to have a perfect sampling rate that samples the 32 per wavelength, 32 samples. So we get the sample. We need to sample position needs to be rubber ducking development. What is it? Samples per byte -1. Okay, so that starts over. Then it tries to decode the byte from the samples, and from the current sample state, if it's in sync, then it increases the samples for the current byte, and if the samples per byte is reached, so we have a new block of samples that where a byte would be encoded, we store the byte in the buffer and basically continue. Otherwise, if we are not in sync yet, it just checks every like new sample if the decoded byte matches that. Now we are not checking the power yet, so it could decode with being like slightly shifted in the phase. It could decode, but not reliably. So we need to like check that to basically, before we consider the sync be ready, that the new decoded byte match is slightly worse in power as a result than the one before. Then we know, okay, now we are at the peak, or we were at the peak the sample before, and that was basically our starting point. Yeah, we could also adjust the sync, but we will do this later. This is I think, yeah, for now let's just try to get a few bytes in. How does the decoding of the byte work? Decoding of the byte is basically, yeah, there's mask calculated again, 8 bits times 32 samples, -1 is the mask, and then I will explain that. We are basically taking the peaks of the waves for each. This is our estimated power, and then we compare basically the square, because yeah, that's easier than using ABS in that case. But I need to halve that. We can check that with paint. So okay, that's a bad sign. It's more like that. And then we have something like that. Oops. That last part is not that great. But what I'm doing is to decide like what is the power of one will be picked up, like if these are our samples, I pick up the power here and I add this and subtract this, and then we have like this will be, yeah, this is off. This will be rather like that. Okay, so this curve will be 0, 0, while the lower frequency is 2 in the sum, and this is already confusing. Let me erase that, because we have twice the frequency for the zeros. And then of course we have the same with this one. I will add, oops, I'm adding this and this and subtracting this and this. Hi, Ice. Hey, Rubbish. Did my bot die? Can't hear you. Yeah, so I'm having twice as many samples for the higher thing, so I need to divide this by 2. So let's do that. And I think that should be it. What happens when I decode the sample buffer? 1600. Oh, I'm not even storing that many samples. Okay, let's do it. Let me upload that. We will run the test. There's the recorder in the background. Connect. Okay, it's rewound. Yeah, no FFT, nothing. If you set the sampling rate to the right size, like we could also limit if we have like a constant wavelength that we want to check, we could even like sample only like what is it, 8 samples per wavelength. But I want more, like I want 32 samples. Yeah, you can just take these values and this should be 1 and this should be 0. So very discrete check here for those, like to distinguish between those two. If we have other frequencies, they might still like be picked up, whatever. If when I have like the higher sampling, so we have 32 instead of 8, so we have like 3 steps in between, and then we can measure. Basically, you can see there is the peak. If the peak is slightly off, we will measure at the end the higher power, and the power is basically the calculation from this plus this or minus this, and then power, that's the calculation. So this value will be lower and lower if we are slightly off. So we can find the center but by just looking at the samples. What is it, like 3 or 4 samples to the left and right to sync up again. That's at least my approach. If it works, we will see soon. Okay, let's run the record test. Uh-oh. It didn't start the recorder. I don't know what's going on. I saw this issues before. Maybe my pull down isn't good enough. Oh wow. Hey Basil. It's stuck. How long does it take to encode that? It rewinds. It didn't start the record. Let me check if that works. Stop. I don't know why. When I press the button it works, but not when I do... Oh, now it works. Okay. Here we go. Not very reliable. Oh, by the way, the PCB is is this the same size as the device, so I can put it in one case. Oh yeah, that's a new board. You missed the beginning. You just need to rewatch the first, like, I don't know, 10 minutes where I explain everything. That's our DAC and ADC board with perf board possibilities. Okay, it's rewinding, so we will have our test. Let's listen to the test in now. Okay, so sorry. Okay, so we can zoom in actually to see the two zeros here. So we have two waves, then we have two ones, two zeros. Then there's a one, then 0, and then 1, and then we start the data, which is basically incrementing up to 16. So I can rewind again, and we will try to decode, and it should maybe show what we decoded if it is successful. Sorry, quite noisy. I don't know if it's decoding or not. Oh, it decoded something. Oh, it lost. Oh, wait a second. Okay, interesting. We got some data in the beginning, but then I would need like to resync again. Huh. Yeah, data is faulty. Sample rate too high. No. I need to. Yeah, I could do the sample rate like lower. We can try with what is it? 1, 2, 3, 4, 5. No. 4, 8 per. We can try that. Decode. So will be basically 8. No, nothing yet. This is the first time. This is the first time we're trying it. This is your life. Your life the first time we're trying. We will improve that. I lower the sample rate, and then it might work better for now before I search for the best thing. Oh, there are problems. Ah yeah, get power. It's not used yet. Okay. Oh yeah, I should also not try to read that much. Let's try only 60. 16 bytes, because we have like 16 byte blocks. Or I will improve that by let's do this. 256, and then we will do So you will see something more significant. Okay, but we need to run a new recording test then. Okay. I hope I changed all the... Oh yeah, we need to reconnect. Upsala. Yeah. Frequency 8. Oh yeah, this is then wrong. I need to do plus 2 plus 6 1 7. Oh wait, no. This is 4, that's 5. That's 7. Nope. Wait. That's 3. 3, 5, 7. I need to calculate that. I hope this is right. Let me check. First one is 2, that's correct. 6, correct. 1, 3, 5, 7, that's correct, okay. Very crude, just using the exact sampling rate. Oh no, didn't start record. Need to wait now. Do I? Oh yeah. I don't know why record is refusing to do whatever. Oh no! Again. Need to change that. Somehow record needs more time or something. Let me check that. Record. Just increase it by 2. Because that's and also I don't want it 20 times. It's probably sufficient to do 4 times. it works. Okay. Okay, should we listen? Let's listen. You can literally hear when it's the new block starts. Oh. Okay. Now let's do the retest. Ah! Oh no! I need to deactivate read ADC. It found the sync, but the data is off. This is completely messed up. Oh no. It finds the sync byte, but it doesn't look very good. Okay. I will change back the sampling rate to what I had before. Before I destroy everything. Oh yeah. So, divided by 1. Hey Christopher! Long time no see! Or have you been lately on my stream? We would need to tune a little bit. Sure, have been busy. Oh, what have you been up to lately? No. Okay. Let's try a lower frequency, but we get more noise on lower frequencies, my friends. So if we try like something like 500 Hertz, that's not necessarily better. Oh yeah, working. Yeah, same here. At least I had quite some success with the latest video. 1.1 million views! Yay! Okay. Upload, yeah. But we have to re-record it, and it will be a lower frequency. I noticed that on higher frequencies the wave looks nicer. Then we have more noise on the lower frequencies for whatever reason. Probably because the electronics, the stuff here, motor and 60. Yeah, no, we will measure the power and then try to figure out if we can improve the sync. So I will search the peak of the sync. Okay, but first let's try out this one. Hey, I'm a boy. It was great. I showed a few pictures in the beginning of the stream. So if you're interested, yeah, I didn't die. That's great. Hey, 404. Okay, record test. Oh no, didn't work again. What's going on? Something's fishy here. Maybe there's a stronger pull up or something. The record refuses to work. I would need to check. Yeah, nothing happens there. Huh? Now it doesn't want to. Come on. Huh? Just Mark, hello. How does JavaScript access data from microcontroller? Serial, web serial. Do you see that symbol? We connect and then... Ah, shit. This is somehow currently refusing to do any work at all. Maybe the... What's going on? Is it the recording? Oh. It was in a weird state. Oh. And it's also... Rewinding now. Oh, I can lower the volume, by the way. Doesn't need to shout at you. Shit. Or let me do it with the... Baud rate, I think we did 1 million. But it's not proven that it's actually a million. Come on, decide. Boot up already. Okay. I might want to gigabaud. Hook probes here. I think I have a higher voltage for my recorder, and that's why the voltage divider might be not suitable. I might want to use different values on the resistors there. All right, play. Lower frequency, you can hear it. You can see there is some weirdness going on, but overall it should be all right. This is more clear, probably. The ones and zeros. Okay, retest. DAC output, yeah, it doesn't need filtering. It's so clean. Structure evolves. Yeah, it is a ramp. You can see it's a ramp. Maybe it's inverted. How would it look like if it's inverted? Is it inverted? No, it's not inverted, is it? Inverted would be still a slope, a clear slope. Okay, let's maximize the power then. No, let's not start at the best thing. Okay, so we have decode byte. Wondering it might be too much already. Or let's do the quadratic here. And then we do okay, so we calculate the power, then what we do now is sync power. We don't do that yet. There is no way of, without debugging, to see if that actually works. Okay, if we decode the byte, let's check for the power. So we could also lose sync as well. Wait a second. The sync byte also happens to appear in our regular data. Anyways, okay, if max power, sync power, then do the following. At some point it will be lower, else we do the following. Sync is true. Is this correct? Because we have already one sample in. Now that the sync is not higher. Okay, yeah. Let's see if that works. Still the problem. Yeah, we don't need that part here. We can also see what kind of we can debug that, but I want to see. We don't need to record because we have still the stuff there. Now retest. Data's still messed up. Overcooked, undercooked. Okay, let's debug it. Can remove that because of hey Nishai. No. Here. Let's see the case when it starts. But of course maybe we should sample beforehand because this is now impossible to debug. Like we can get the next byte or whatever. What do you think? Should we just sample it and then try raw slope and yeah, no, Actually not, because it's not that would be amplitude modulation or amplitude or there is no absolute position. Printf debugging. No, we could sample the audio data, send it over serial, and then test around and develop a method in JavaScript with the data that we were able to record. Maybe we can even record multiple data sets, and once it's robust we can transfer it to C++ and see if it's working. But I want to see what power level we reach. Maybe we had an overflow or something, because we also look at that. The samples are in 16-bit. Yeah, no, this is the power is too high. That sounds stupid. Let's do it. Yeah, we probably get an overflow here because we have a quadratic. Yeah, already this multiplication. Let's see. I don't like it, but I do it. Oops. Not even sure if we are able to calculate it on the fly, performance-wise. Because we are iterating. How many cycles do we have per sample? If we have 500 times 32, let me calculate it. What is it? Like, let's see, 1 kilohertz. That's 32,000. Okay, that's 144 divided by 32,000. 4,500 cycles should be enough, actually. Don't think we're undersampling or whatever. Where was I? Oh yeah, 64, and we have a power here. And let's debug it. Maybe there should be a threshold. Yes, it's signed, but we are multiplying. We are making them quadratic here. We could also use ABS, but I don't think I have ABS for integer. Okay, wait. Retest. Huh? Didn't work. Let me clear that. Huh? Huh? Oh, now it fails. Oh, we're there. Oh, it's 11K. But why didn't we get this one here? There is no way we'll ever get there. Okay. Seem have to recall something. Wait, sync. Else. Huh? What's going on? It needs to go there. What failed? What failed? Oh yeah. Okay. Huh? Is there like a invisible breakpoint? Ah. No. Hmm. What were the values? Oh, by the way, we can maybe auto level them, but they seem to be more or less centered. No, they're not. Actually, That might be a hint, Sonic. Let's try to balance them. So yeah, it we have like an 8-bit and a 14-bit, no, 12-bit. That's why it's. Is it correct? Yes. For 12-bit, it should be center. But we can calculate that because yes. So we do 0 sum minus samples. The sum of the wavelength should be 0, more or less. Minus equals sample pause. And then, oh shoot. No, we can't do that because we have already, or we shifted later. 0 sum, and then we pass it here, power 0 sum. What is 32 times 8 is 256, so 8. Yeah. And then or 0. Yeah, that's plus and minus 0. That's the sum of that. That's minus plus 0. No, it's irrelevant here. That's not relevant. Look at that. We have like, if we have like a DC shift, the DC shift is always subtracted with this sample, with the second sample. So we don't actually need this DC shift at all. So that doesn't need to be calculated. 0 sum. Let's remove that. It's only confusing. Where's our 0 sum here? Yeah. Doesn't do anything. All right. What I will do now is I will sample the bytes and we will take a look at our algorithm in JavaScript, okay? So this will be hopefully more revealing. But we have plenty of possibilities to mess up with the types. As soon as I know JavaScript works with basically the same recording, we can do whatever. Okay, so our buffer is I think 40 kilobytes. So let's do that. We will record the packet. So, oh yeah. Sample buffer and then record new or record samples. Sample buffer 40k. Sounds like Warhammer. What is this? Amps. Sonic, I know you're a sci-fi fan. I must admit, I never read any books about Warhammer 40k or never watched any content. Ah, right. Where do you know? Where do you know there is an emperor? Where do you know that from? Oh, does he paint the figurines? Oh, resin. Yeah, that's cool. Actually, that's super simple. I mean, you can probably save a lot of money doing like buying a resin printer. They should be also quite cheap, like $200 or something, for entry level resin printer. You don't need like for the figurines. You don't like need a huge building volume. The Shipu, you know reveal that you are Warhammer fan. Kill team? What is kill? I have no clue what. You play Warhammer, like with the figurines with someone else, or? Ah, I have no clue who that is. Games Workshop Central to get some rule book. Alright. Okay, we need to shift this by 4, otherwise Ah, XCOM. Yeah, I loved XCOM. I mean, not the super old ones, but I played the XCOM 3. No, what was that one that came out on PC and Xbox in the 2000s? I like that. I like round-based games, turn-based games. Sorry, round. Okay, last ADC gets time sample. You still play? Really? Nice. Sync buffer position ticks. Okay. We don't need that. What we can do is now we will. Yes. Really. And do you still play Fallout 1 and 2? Wasteland 3? What is Wasteland? It looks modern. Oh really? I liked the mood, like the music. Hey, Wigan Loads. The music of like the first two. No, the first two were epic. Like really really good. The mood and the music was amazing. Yeah. I'm also more of a Master of Orion guy. Played that a lot. All right. Yeah, we can record a sample and then no, we can record 40,000 samples when we connect, hopefully. Okay, now. And then try decoding them. But I need also to decode how do we do this? Okay, we then get this is what we get. Oh, 40k samples isn't much. We could even get a little bit more resolution out of that. It feels like doubling might hurt it. We might get clipping. Let's not do any doubling or anything. The lower frequency already looks terrible here, but let's take the lower frequency as it is, and try to make it work with that. So now we will switch to what was this? Test 1, test. Now we will decode it. Draw scope. Buffer. Where's the buffer? Buffer canvas width. Okay. I need a little bit more space, sorry. Let's do 40K. No, there is a filled 0. Okay. Raw, and then we will, whenever this is done, read loop. Yeah. Copy within. And we will do also raw pause plus plus okay, so, and we also do function plot value and then do that. So we can use that later. Plot. Okay. What? Wait, what do you have that might work? Need raw pause. Let raw pause. Nobody saw that. And we do like a button decode. Huh? Where's the text area? That was stupid. I deactivated Copilot, by the way. Decode. Decode, okay. Now we can decode. When is the refresh happening, by the way? Is it when is Troscope happening? Oh, request animation frame, alright. That's perfect. Decode. Now for that's cool. Is it fixed frequency or no? Yeah, one frequency at a time. What happens if you have like overtones, undertones, noise? How does that work? Okay, by the way, sorry. read loop, raw pause, oh. I'm getting tired. Okay, we need to hurry up before I fall asleep. Yeah? Ah, yeah, that would be yeah, we could do this with FFT, but I mean, we tried storing 8 bits at a time. Dudes, I'm trying to do as simple as possible here. I'm not trying to start like a company. This is a project that just needs to barely work for a video, and then we start to optimize. Function first. Oh. Oh wow. Okay, we trying to find the sync. Okay, so function decode byte raw. Wait, we know raw. It's a global thing here. Decode byte start. For, oh yeah. Okay, let's try again with const. Yeah, let pop be raw start plus, what is it, 32 16 8 minus raw start. Oh wait, it's not great. Start time. Oh wait, no, start 32, no, I times 32 plus, did I do this wrong? Did I do it right or wrong? Left 5. We can do times 32. We need a safe implementation here. Might be a source of an error. Let me check. No, that's correct. Plus 24. That's pop 1. p. Is it 4, 12, uh, 20, 28. Did I get this right? Yes, it's 28. All right. What I could do is I could record the samples starting from a silence, like finding a silent block. That's the start of our data block, recording that, stopping at the next silence, and decoding it afterwards. So that might be a solution. Okay, so I want to divide it by 2. I also want pop voice scrambler. What does a voice scrambler do? Oh, did you want to blackmail someone on the phone? B or equals 1 shift I power. Oh yeah, we can measure the power here. Let how does that sound? How do I return power here? We can return both. Start as I. How do you do a tuple in JavaScript? do that? Okay. Byte power turn B power. That's a tuple. Oh yeah, I wanted to plot it. Console log, by the way. We can console log log that and plots B. Oh wait, this is when if B equals, what is it? And no, it's 1 1 here, 0 0 here, 1 0 1. Is it this byte? Yeah, I think it's the same one. Okay. Then we have to let's start with the sync. True. If sync, then do following. Oh yeah, we need to increment also. So we need to do the counting. Okay. Was it byte samples? I have no clue. Wait a second, how do I do it? Sync. Oh yeah. Almost. So this is decode byte plots here. Eight times 32. Sync Okay. Let's try. Oh, it didn't decode. Let me check if we ever get here. Decode byte. Yeah, we probably never have the silence in there. Let me check it here. Oh. Huh? Her? Oh. Wait a second. Oh. That's the wrong position. We just received it. We need to do it here. Yeah. Oh. Sync that. That's not good. Fifths. That's not what I would say it's a sync or anything. What position is that? I need a position as well. Oh yeah, I have a good position power. Yes, it's printf debugging. That's for sure. Okay. So we need a certain level where we sync it up. So it's terrible. Retest. This is like, this should be more than 23. We have like, okay, let me check. Position 399. Okay, what I will do now is I will plot out. Why is it this one here? Decode byte. Oh wait. Yeah. Oh! Look at this! It has decoded something. This looks like the correct data. What? But this doesn't here. Decoder says I'm Batman, yeah. This is now interesting. I would say we plot when I see the sync. Yes, something randomly. No, we have like we stored in the data. We stored the basic increasing. How does my tape? Some mechanical stop there. We can read this from ADC at some point. I don't know. I will just rewind until it stops. It changes the level of the ADC when it's running, the motor. So I know when it's still rewinding. And from that, I could also use different GPIOs to get that. I mean, we have some perfbot real estate here. But yeah, for now, I'm only worried how to store the data. Then we will see further. For let J I minus, let's do 2 wavelengths. Oh, is there a fly? Oh, stupid fly in my room. I hate flies. 32. No, it doesn't have a start and end tone. Oh wait, this is the starting point. Oh no, wait. Let's do that. We want to see what is fly. We want to see the data. Okay, so now it will just plot the data from where it's supposed to find, supposedly found the start of the sync. So connect. Yeah, it's dark already. Birds jumping. Yeah. Hey Jay, Jay the developer. Hello, welcome to the crew. Yeah, we're developing the next video, which is a pain in the ass again. Storing data on a micro cassette, and I'm trying to decode whatever I recorded there. Okay, read ADC, no, read test. Let's get the data from the tape. Now let's decode. Oh. This is our data. This random noise is our sync signal. Alright, okay, peeps. That's no good. Okay, power needs to be what? Greater than. I would say greater than 100, okay? This is just random. Ship it. Yeah. Johnny, you should do it yourself. You got a job. Okay. Oh, this peak. No, where does the noise start? Huh? Sync position 513. This is it. The click triggered it. Damn it. Okay, let's do 1000. 1000 is our power. Nah. Scope, not. Scope doesn't help. This is our scope. Also, scope is running all the time here. Okay, retest. Ah! Look at that! How about this? Now it detected the right stuff here. And power is 7000. So actually we might be able. Okay, what do we decode here? We need a lower power limit. And with noise, there is always some crappy stuff going on. So let's not do this anymore. Yeah. Now we will see what we decode there. Yeah. It starts alright. So it actually found the right start, but we have some errors here. Let's see the values that we were able to decode. Oh, peeps. I need to record this. So, this is our input signal. This is what we decoded. It should be increasing from 0. And we have 0, 1, 2, 3, 4, 5. Ah, the 6 is broken. 6 is broken. 7, 8, 9, 10, 11. Oh, 12 is broken. 13, 14, 18. We're losing the sync. But it looks alright. I mean, we have some numbers here. What is FEC? What is an FEC? Vorwärtsfehlerkorrektur. Forward error correction. Oh, wow. Oleg, no. Wrong place in the pipeline. Getting out of sync, but the power level doesn't indicate that at all. Look at that. In the beginning, we have really weak. Oh, wait! Let's adjust the power like we did with our other thing. So, sync power. Like we did on that. So, if sync power is lower than power, then do power, and then we have else sync -1 and bytes samples is 1. Okay, so sync is true. This is we look for the highest sync here. Our sync power was 6,300. Maybe we can improve on that. Okay, but I see progress. I see progress. Let's look. Let's look. Okay, wait. I record this for. Let's look. What do we got? Ah! Ah! Look at this! Looks even better. We get. The first 8 bytes are correct. Ninth byte is broken. But we're good. So here is 9. What is flipped in 9? Well, there are some bits flipped here. But the power doesn't look like it's in. Look at that power. What is going on here? Oh, I think the lower frequency has a lower amplitude because of that cutoffs here. That's why the power with a lot of ones? No. 2 doesn't have a lot of ones. These have the same amount of ones. It's so extreme with the square root. Yeah, we do sync. We would need to adjust the sync. Hey, I did that. So how do we synchronize again? And we have some flipped bits here. Ay 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 ay. So 127. 9 is completely different from 127. There's some noise picked up here. Look at that. I don't like how this looks like. Maybe we should try, peeps, we should try something different. We should try a higher frequency where we don't have these noises. Let's do 800 again. but we need to re-record that. Sync character. Oh, yeah, but we saw the first. Ah. How does UART do it? They sync up as well with start and stop bits. Huh. Sending zeros. Yeah. Every 8 bytes, one sync byte again. Ay, peeps. You killing me. Chunk it up. No. Let's try the higher frequency first. And then see what happens. Forced penguin. Do we have to worry about wow and flutter leading to inconsistent timing, thus requiring to sync periodically in some way? Yes, that's basically the main issue here. So we have some kind of drift. The playback and the recording speed could be also different because this is an analog device. That's why it's not consistent. One, yeah. I would assume that we can. What do we do here? Oh, by the way, I also received another device. Where is it? I can show you a very crude one. It's very mechanical only, but it uses also microcassette. So here it is. Look at that! Hee hee! Yeah. We have our first recordings. Can we play that? Oh, this is. Wait, is it broken? No. I don't know if it's broken or not, but we wanted to sacrifice one for the head. I think I'm rewinding wrong direction. Oh no. Let me rewind. Oh. Oh, is the battery done? No. Eh? Oh, this is really bad, this thing. Oh, okay, let's play it. Okay.
Blah blah blah.
Playback speed. I don't know if this is the right side. Anyways, this one is our test device. Woodpecker in his prime. Okay. Yeah, we wanted to connect, rewind. Record a test. New frequency. It's automatically rewinding after record test because it was annoying. Okay, then we have read test. Look at that. Look how beautiful that looks. Ah, nice. This is something. This is something. Peeps. Okay, let's try to decode it. Boom. Look at this. Look at this. Higher frequency, the better. Only a few flip bits. Here, 5 and 13 is just bit number like 3 is flipped. Then we have a lot of stuff going on. 17, there is something, I think 32 or something is flipped. Oh, what's going on here? Okay, this is 19. 19 is, the 4 is flipped. Then we have, what is here flipped? Another, yeah. This looks solid, and now then it loses the... Look how crisp the power level is. Okay, so higher frequency, better response. No, it's the 1 wave per bit. We could do more cycles per bit to have, yeah, we halve the basically the baud rate. If we do that, we could do it. That's an option. Certainly. We can increase the frequency even more. Let's do 1200. Yeah, we can do 10 times. Maybe higher density is better in that case. We do double the frequency. Oh, by the way, when I try to play back at 4 kilohertz or something, we can't see it live because sending the sample over Doppler shift, turbo tape stuff. Yeah, I could do that. Connect. Then read 7 next bit to verify. Okay. Well, it's a lot of bytes. We need to just resync. I think we can use a Markov pattern. Start-stop bits might be actually a thing here, because we can be sure that it's a frame of the byte. We can adjust the frame each byte. But first we will record test. It's FPGA again. Yeah, we might want like more sync bytes. Okay, retest. Whoa, that was fast. 40 kilo samples. Look at that. Oh, nice. What is this? Boom. Okay, let's see what it decoded. Ah, shit, it fell apart. That's not good. Oh no, I don't think it even found the right starting point. What is this? Oh no. But it looks so good. Ah. Let me retest again. Ah, no. The higher frequency is too low. Okay, let me change something. Higher frequency response. Oh. Oh, wait! Why do we shift by 2? That must be 1 at most. In that case, I would even say it's 0. Nobody told me there is an error here. Beeps. That was the error. Yeah. Okay. Nope. Still broken. Broken. Yeah. Of course. Okay, let's do no at all, because we can see the amplitude of the lower frequency as twice the one of the higher frequency. So now we are in tuning, optimizing stuff here. Moment of truth. Moment of truth. Oh! Look at this! Oh, wait a second. We are decoding the wrong frequency. Are we? No, we're not. That's independent. But where? No. No, that doesn't look good. Hey, Mellow Labs. So this looks like there is something, but it's not correct. Why is it? We have consecutive. What? It's skipping like 4. Wait a second. That looks like the sampling is wrong. Maybe it doesn't sample fast enough. Wait a second. Let me check the ADC. ADC samples. What is 28 cycles 5? Is it 28 times 5? No. I need to check the Nyquist's Revenge. Why would it skip every like fourth value? 12, 16, 32. It looks like it's skipping. Let me check. 1200. Okay, let me rewind. Maybe it's just an old recording. No. Look at this. Wait. Not a number? What? Oh, that was... Oh. Wait a second. Do I start a new sync? Why don't I see a new sync here? Huh? Okay, raw plus 28, it's at the end. Nah. It's reading out of bounds or something. Yeah. It's probably reading out of bounds here. This is where it restarts. But I don't see a new sync though. Where is this here? Decode. Okay, let me clear that and decode again. Huh? What's going on? Na, Batman. Huh? Wait a second. We should be here at some point. Oh, sync power is lower. What is our sync power? No. No. That doesn't look like it's... should be lower than that. Huh? How does it gain sync here? Okay, let's run again. Huh? Console log. Wait. Is this the problem? Oh no. Yeah, it was just a display issue. Yeah, sync boss 32 power. Okay. So look at this. We get the first 6 we get right. 7 is wrong. No, it's correct. Look at this. We get 9, then 10 is wrong. 13, 15, 17. So here we can see there is actually some... It picked up something. Wait. Retest. And decode again. Oops. And let's see. Started. Oh, did you hear this? That was the start of the new packet, but didn't get that right. Let's decode again. Yeah, the power is too low. It's in the middle of nowhere. So I will probably consider any power of Batmobile. Okay. Let's see what it did. Yeah, it started okay. The first 6 bytes alright, then 7 byte is broken. 8, 9, and we get already a sync is broken. Okay, that's already a good success so far. How does UART work? What we can try is, like, if we have 1. Okay, we have what, 1 and 1, and this means we okay, let's do so we read 10 bits and we try to resync here, like readjust a sample back and forth each byte, checking if the sync is better this way or this way. What do you think? Does this work? Or we can only do it like 0 start, just one bit in the beginning. In the beginning. Sonic, what? I will rewind the stream and we will check. Yeah, I know. I just wanted to see if our other method works. I mean, we had some better. Now we improved. What did we improve? Oh yeah, what we can also do. We changed like the division during the decoding. We changed the division. 0 on start and 1 at the end. Okay. This is UART. This is how UART does it. Let us try it. Okay, here is the... what is fly? It's driving me nuts. Oh, come on. Where's the graphics? The diagram. Here is the diagram. Stop. Start bit, idle. Byte frame, yeah. Also the 2 stop bits. Or 1 stop bit should be enough. Yeah, no, we have like silent between bytes. No, the problem is the swinging. Oh, this fly. Oh! I think I got it. Yes, I got it! Ah, it's dead. You just need to flick it frontally, because flies only fly forward. X-fly, yeah. Ah, that's good. If you flick it, it will be confused and land on the floor, and then you can step on it. The resyncing is quite easy. Let's try the different frequency. What did we do? 800 or 1000? I want a pond with dragonflies, and I will just have some dragonflies flying around here and eating all the mosquitoes as well. Okay, let's connect, but we need to still flies. Oh, damn it. I have plenty of spiders here. They eat all the small insects. I love spiders. I leave them at home. They can reside here. Oh, please, I'm feeling so tired. Ah. What is this? What is this? Hmm. That starting point looks actually alright, but you can see what is going on here. Yeah, 3, 4, 4. During the 4 there's a flip bit. Also 6 there is a flip. Oh, this is terrible. Even the other one. Know why it stopped so early, but 7, 8, yeah, there is this bit 16 is flipped. Okay, what we could do, we could improve our sampling technique. This is something that I could do right now. Okay, what we are doing right now is here. We are sampling only here and here. That's not inverted boobies. We could also sample here, 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 and here to get a better understanding. We have the sampling rate. AI boobies. And demonetized. Okay, let's try that. That should be easy. I mean, that's a... Your laptop? What? No. It's not local maxima search. It just error, more error proof. To noise at least. Bring Looney back to Jesus. What? Okay, peeps, let's do it. So, wait, 8, 10, no. Wait, what? No. +4. But this is... $12 minus... Wait. But this will... Okay, yeah, I don't know, this should be 0. It might improve. It's not a gradient descent, we are not doing any of that. That's because, oh, look at that, we have samples that are similar. Okay, we sampling that. We need to double that. So you know what? It's just the same times 2. Okay, so this will be... Oh, wait. I will flip this because we are adding those 24, 28. Okay. Now this will be 2, 4, 6 minus 6, 8, 10, 12, 14, and then repeat this. Let me finish that, please. And then we do the same with 16. That's 18, 20, 22. And then we skip some, 26, 28. No! I'm picking up the samples. Wait, I will show you again. Okay. This is done. So what I'm doing now is I'm sampling the 0 has a lower frequency, and I'm taking these samples here minus these samples here. And I'm doing the same for one. It's not magic numbers. It's discrete Fourier transform with just taking the samples. Because not in that case. Anyways, we have a moving frame and we can test for that, and that maximizes the power. We will see here. It's not Fourier, it's just a plain Looney FFT. FFT would be more sophisticated. Oh, we get a not a number. Look at this. Looks promising. Oh, there is a 6. One error until we get only the bit flip here. And we have stored 16, 17, 18 bytes correctly. Doing that. We can probably do another test. Okay. Oh, we should also do a higher sync signal. Look at that, 69K, wow. Okay, decode. Oh, I didn't. Ooh. Nobody saw that. Nobody saw that. Ah, shit. Doesn't look great. Okay. Fast, make a clip of that. Yeah, let's see again. Nah. I'm losing it. Whoa, what is going on here? Hashtag tempted. Yeah, that didn't work as well as planned. Okay, you know what? I copy these two rows. That was pretty, yeah. Let me rewind this change because we pretty useless. Ah! Thank you for... That's just a DFT with discrete values. We'll keep that one. You would usually multiply with sine, but sinus is basically 1 here and -1 here. That's why you just take this sample minus this sample, and this is just in DFT. Same with these here. You take this sample and this sample, that's 1, that's -1. That's equals like sine of pi half equals 1. something like that. It's just discrete stuff. You know where I used it? I used it in the video with the ultrasonic scanner. There I was using an Arduino Nano on the pick and place machine to map out the ray of the ultrasonic beam, or like the intensity of the ultrasonic beam, and I used basically the same function. I set the sampling rate, it was like 40k was the frequency of the ultrasonic transducers, and I just sampled, like oversampled 4 times, and then picked basically those samples and calculated like that the power of the beam, and it worked. So I know my stuff here. Yeah, in this case it doesn't. I'm too lazy to implement the start stop bits. You people are making... Okay, let's do start stop bits. Is it a starting 0 and then stopping 0, or what stopping 1? No, it's -1, minus 1. So it's 2, Johnny. You're missing the part. I'm taking this value and subtracting this value, which is -1. Minus is plus. Welcome. Do you see that? Here. Yes. Here. This is plus, or here, this is the case. It's inverted anyways. This is plus, this is minus. Plus, minus is twice as much. Nailed it. Pay attention. I learned a good response. I'm giving lessons, Johnny. If you need, I'm giving lessons. Anyways, scope is off. I'm trying. I will check if we can add decode, encode packet, encode byte. Framed byte is basically, we start with that and do that. And the bit is basically, this is it. This was the encoding. Oh, that's too complicated, wagon loads. We will just resync each byte. That will be alright. We can just the only thing that we need to do is when scanning testing like back and forth a little bit. We know that this I think this will be alright. We can use that. Okay, but we need to re-record. Oh, we can also try something else. Instead of doing that, we use shorter messages. So rather do 64 bytes and 40 times. So we have certainly a start of a frame in our recording. That would be alright. We can also resync each individual byte. Like after a byte, drop off the sync, and then the first one will be always alright. You know, we have now, what we have now is just silence. Then we have our sync byte, and then there is the data byte is instantly after that. And we could just hit after each byte. That will certainly more than half our rate, but if it's working, I mean, I will certainly try it. All right, connect. Oh. The sync byte will be also framed. Interesting. Okay. So we need to consider that during decoding. I was recording quite some frames there. Okay. Oops. Ah. Decode byte. Decode byte does 10 bits. Now, and what we have is a 1. A 1 here and a 0 here. And plot okay, let me do that. There is no sync improvement yet. Oh, my head is stalling already. Why is it reading so much? Huh? Huh? What happened? Did it crash? Huh? It's broken. Okay, let me rewind and let's try again. From Alaska. Huh? It should stop already. Now it's completely broken. Huh? Huh? I'm confused. Record sample buffer write flush. Ah, shoot. I have no clue what's going on right now. I can debug it. So I would do that. Why would it stop working there? Shortwave radio. Okay. Oh, it didn't find the sync, or what is going on here? Console. What's broken? Oh yeah. New cassette. No, this is alright. Let me check if the power $5K. Okay. Oops. Oh, it doesn't decode the... Okay, what do we get here? Wireshark? I don't know. Ten bits. Now that looks like that should work. Decode byte. Either I did something wrong. While encoding it. No, I'm not doing a real scope today. I think the time wants me to go to bed and you need to come back on Wednesday. I will check if I messed up, but this is sending frame bytes. Oh yeah, I messed up. Shoot. Yeah. Okay, let's try again. And I need to... Okay. The recall test is quite long. Oh. Sorry. I have no clue. Why it's failing here. For whatever reason, it doesn't do this. It's locked up there. Anyways. Okay. Now, yes, we got the decoding. Okay, 10 bits. Hey Artem! Oh no, this looks not what I encrypted, yes. At least I don't see values higher than 256. Random. Certainly. I see a pattern here. I see a pattern. There is a sync. Look at that. Let me check for the sync. Sync position shouldn't be that far. Huh? Wait a second. Why doesn't it... That's like 256. Sync position should be quite in the start. Maybe. People, I think I'm done for today. I'm so tired, I can't concentrate anymore. Signal looks alright, but you can see like the first zero or whatever it is do we have 0 on the right? Let me check. Is it a 0? Yes, it is a 0. Yeah, this peak is quite low. What we need to do is now to... You can see the pattern though. There should be like a stop bit, start bit. Yeah, this is a 1, I think. Anyways, I'm done for today. Thank you everyone for joining the stream. I will be streaming on Wednesday because tomorrow is Hangout. Otherwise I would stream tomorrow. But I will try to finish that. I mean, you can see this is what I did on the weekend, so I'm productive. And let's look at it at this beauty. Look at this. And this will fit in here and sandwich like that. This will be awesome. This will be awesome. In the beginning it mattered that inverted 8008s changed the history. Alright, I see you on Wednesday. Bye bye everyone and have a good night. I will have one. I will sleep tight. Bye bye.